technology organization, and my specialism is in the dating methods using those nuclear techniques. I'm really interested in the environmental history, in particularly Java. We have a lot to learn from past climate and environmental changes and how we can deal with them in the future. So if you have an interesting project, don't hesitate to contact me. I have an email address here at ANSTO, or you can ask Professor Tri Sukrubawati.
Now I'm studying Master of Epidemiology in Universitas Diponegoro. I choose Undip because
if you have an interesting project,
the best university.
Don't hesitate to contact me. I have an email
Secondly,
address
they have a good Master of Epidemiology. When I say it's a good one, because they have good laboratory settings. They also have good lecturers. They are professional, and anything you need to do a research in Undip is there.
I recommend other foreign students to come in to study in Universitas Diponegoro because it's a good place and a good environment for studying. So I say others are welcome. The language wouldn't be a barrier because you're going to learn it in a very short period of time. Thank you.
I choosing Master Epidemiology in Diponegoro University because one of the mission is conducting research based in the community service and conducting research in the field of the epidemiology that produce publication, policy recommendation, and intervention innovation.
The postgraduates of Diponegoro University carry out international education for the development of science and technology.
Visi Sekolah Pasca Sarjana tahun 2020-2024 adalah menjadi sekolah pasca sarjana bertaraf internasional yang unggul dan terkemuka dengan mengintegrasikan bidang keilmuan multidisiplin. Misi sekolah pasca sarjana: 1. Meningkatkan kualitas dan kuantitas pendidikan pasca sarjana multidisiplin sehingga menghasilkan lulusan yang mempunyai keunggulan kompetitif komparatif secara internasional dan berkontribusi pada pengembangan ilmu pengetahuan, teknologi, dan seni. 2. Meningkatkan kualitas dan kuantitas penelitian dan publikasi sebagai upaya pengembangan ilmu, teknologi, dan seni dengan mengedepankan budaya dan sumber daya lokal dengan pendekatan intra dan interdisiplin. Ketiga, meningkatkan kualitas dan kuantitas pengabdian kepada masyarakat sebagai upaya penerapan dan pengembangan ilmu pengetahuan, teknologi, dan seni melalui pendekatan multi, intra, dan interdisiplin.
Postgraduates of Diponegoro University facilitate students from multidisciplines to develop their capabilities and capacities as academic or professional.
Sebagai bentuk respon terhadap perubahan zaman serta perkembangan ilmu pengetahuan yang begitu cepat, maka Sekolah Pasca Sarjana Universitas Diponegoro hadir untuk meningkatkan kualitas sumber daya manusia yang unggul dan kompetitif baik di skala nasional maupun global. Tuntutan dunia usaha serta industri memberikan persoalan-persoalan yang kompleks dan hanya dapat diselesaikan dengan penguatan pola pembelajaran multi dan interdisiplin keilmuan. Bentuk respon terhadap perubahan perkembangan zaman maka sekolah pascasarjana melakukan reorientasi kurikulum dan pembelajaran di tiap prodinya. Kurikulum dikembangkan untuk lebih fleksibel melalui dua jalur pembelajaran, yaitu program by course dan by research. Saat ini kami mengelola program studi multidisiplin, di antaranya program magister dan doktor ilmu lingkungan.
Well, ladies and gentlemen, may I have your attention, please? Our conference is about to begin in 5 minutes. Please have a nice seat. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Welcome back to the 8th International Conference on Energy, Environment, Epidemiology and Information System, Icenis 2023. I am Niar Chandra Agustin
And Novita Rahmayuna.
as the mistress of ceremony.
So we will continue our agenda on the second day of the conference. Ladies and gentlemen, now we have come to our agenda, the plenary session. The speaker of today's are Associate Professor Sangden Munsong, PhD from Mahidol University, Thailand.
Associate Professor Tomoya Kataoka, PhD from Ehime University, Japan.
Professor Dr. Insinyur Hadianto STMSC IPU from Diponegoro University.
All presentation and discussion will be moderated by our moderator, Mr. Agung Budi Prasetyo, PhD.
Please allow me to read his brief biography. Mr. Agung Budi Prasetyo is an associate professor in Department of Computer Engineering, Diponegoro University. He has finished his bachelor degree in Electrical Engineering, Diponegoro University on 1995. Master in Information Technology, Queensland University of Technology, Brisbane on 2000. And PhD in Computer Engineering from King Saud University, Riyadh on 2015. He also having passion in artificial intelligence and machine learning field for stock trading in Jakarta Stock Exchange. Also, he working in ad hoc networking communication protocols. He has some certification include CCNA Security and CCNA Cybersecurity Operation. Ladies and gentlemen, let's welcome our moderator, Mr. Agung Budi Prasetyo, PhD.
Okay, very good morning. Assalamualaikum warahmatullahi wabarakatuh. Okay, glad for us for having this meeting for the second day of the conference of International Conference on Energy, Environment, Epidemiology and Information System, Icenis 2023. Okay, we would like to invite to come forward the speaker, which are from Associate Professor Mr. Tomoya, sorry. Yes, please come forward. And also Professor Hadianto. Yeah. And the other speaker this one from Thailand, which is Associate Professor Sangdun. I think he's in online. Okay. Is she available for today? Available now? Okay, so she's ready. And apologize, we regret that actually we have 4 speakers, but one speaker sent us a message that he got back pain, so he couldn't come and he couldn't attend for this conference. So apologize for us for this situation, and would like to give you the speeches from, for the first person is from Ms. Sangduen. Okay. Then the second one will be Mr. Toyoma, Dr. Tomoya. Sorry. Okay, and I apologize. Okay. And the last one will be Professor Hadian. Okay. For the first speaker, I would like to read her CV, pretty short CV actually. Dr. Sangdun Mongsum. Okay, very good morning, Dr. Sangdun.
Yes, good morning. Good morning, everyone.
Okay, good morning to you. Sawadi Tong Chau Krap.
สวัสดีค่ะ
Okay, Dr. Sangdun Mongsum, let me introduce yourself. Okay, Dr. Sangdun Mongsum is the director of the Doctor of Philosophy program in Tropical Medicine International Program, Faculty of Tropical Medicine, Mahidol University, Thailand. And she was graduated from Mahidol University, Thailand for her Master of Science in 2004 and also in PhD in 2007. I guess he's been focusing researches on immunological and molecular studies and diagnostic development for tropical diseases. In particular, diseases caused by bacteria and protozoa. Okay, Dr. Mongsum, I think you ready, Doctor? I think we have 30 minutes for you to deliver the speech. Okay, and the title, I haven't got the title yet, so I think you will give it to this audience. Okay, the title by yourself. Then we have 30 minutes for you, and we will postpone the question and answer till the 3 speakers deliver the speeches. So we will put the question and answer at the end of this plenary session. Okay, please, Dr. Sangdun Mongsum. Okay, time is for you.
Thank you very much for the introduction for myself, and also I would like to thank the organizing committee to advise me to give the speech today. Right, and the title of my talk today is I would like to chat about success and lesson learned toward the virtual community of practice. Right, so first of all, I would like to, we know that now, everyone know that we have been facing with the outbreak of the infectious disease as well as the pandemic. The last pandemic that we're facing and still facing is the COVID-19. And beside the facing with the this infectious disease outbreak or pandemic, we are also facing with other challenge they call grand challenge, or even the mega trend like rapid urbanization, demographic and social change, climate change, shift of the economic power, power, and also the very fast change in the technological breakthrough, right? And So this thing makes our work more challenged and more difficult, or some people call that our work gonna be vulgar or volatile, uncertain, and more complex, and also more unpredictable like that. And people call this word as bunny like that. It's more make us more insight about what gonna happen, and we don't know the principle they can apply gonna be fit with those. Anyway, when we are facing with the challenge, the human, right, mankind know how to do that to survive, and we need to develop ourselves and also develop some innovation or intervention to deal with that. And this thing, the most important development is the human capacity development. The human gonna be the key, like gear or key function to change the thing, not something else, not the technology, not the education, but human, right? And when we take a look now, one forum that always update and take a look what we have to adapt, or what the skill that we need to equip us, to prepare us to be ready for the very quick change of our world like that. So the World Economic Forum said that now they predict that from the Treasury research or the survey, right? 50% of the employees need to reskill by 2025 soon, another 2 years. And the critical thinking, problem solving are in the top list of the crucial skills that need for us to deal with some like a disruptive world in the next 5 years. And the skill like a self-management, active learning, resilient, tolerant to some stress and flexibility, also some skill that we need to improve ourselves to be ready for the next 5 years, right? And here also some skill that we call top, some people call 21st, and now maybe not like that and beyond that. This is skill that the ourselves need, or the human need to be equipped with, right? To be what? To get the, to be employed, one thing, to success in our career, and also to be survived in the disruptive world. And how fast that the people always ask that, how fast that we need to improve ourselves to upskill us. Now, the people say that from the survey, right? 40% of the people say that we have to reskill, upskill ourselves, update with the new skill within 5 months, otherwise you're gonna be out of date, right? And some skill, like a marketing skill or develop product development or learn how to use the AI, need to be developed within 2 or 3 months. Let's imagine right now, right? Could we develop or use the AI within 3 months? For me, it's the first one. I'm just wondering that I can do that or not, right? And now go back to I come from Thailand One Health University Network, or Tohun. The network that forms by 2 leading universities in Thailand. This is Mahidol University and Chiang Mai University. And now we have like all of the university, governmental university in Thailand as a member. Now we have 16 university, leading university in Thailand as a member. And the network has been formed to foster one concept we call One Health concept, and also foster the action to secure health of Thai society. And through some activity here, like a key achievement, and like to serve at the One Health literacy or resources, and also provide the One Health educating and training to our students, our worker, and our health professional. And until 2022, we have trained this number about 7,000 people, right? And so because we have to develop some training and educating material and course, at least 5 e-learning course has been developed and available for educating and training during the COVID-19 pandemic, right? And now more branded courses have been customized to offer the interactive and participative educating and training for various. And this kind offer for like various background of the learner, from the basic we call beginning like a learner, competent learner, and advanced or expert learner, like that. And the example of the program that I would like to share with you to let you see success and lesson learned, the way that we would like to achieve the what we call virtual community of practice to do something online, right? So we have one course named International Short Course on the Ecosystem Health, or we call them in short at Tohun Ili, Environmental Literacy Institute. And this course, right, would like to aim to equip the graduate student, worker, governmental worker, and practitioner with One Health concept, One Health skill, and also the skill to design the intervention or innovation to address the One Health issue at the community level, or the community, at least the community that they study. And e-learning is the one basic component of, and also the requirement for this course. And here, right, the basic, right? So the basic have 3 modules. The basic e-learning have 3 modules. Module 1, we call knowledge in One Health issue. One Health issue. The second module is about risk detection analysis. The third module is about the social innovation, intervention, and risk communication, right? And from here, right, and when we this course have been implemented since year 2016, and the e-learning we start to monitor, right, and develop the e-learning in year 2018, and then knowledge, right, and the skills that developed through the e-learning platform has been monitored and assessed. And then we use the pre and post test MCQ to assess that. And here show the result of those assessments. And you see here, this is the dot indicate the score of the student, all the learner, right? The score is ranked from 1 to 100. Full score is 100. And the red one on the left-hand side show the mean of the pre-test score, and on the most right-hand side, a red line indicate the mean of the post-test. And you can see here that there were the shipping of the score, the average score of the learner after the learning in module 1, right? I would like to mention that the learner who participate in this course, normally the course include e-learning and followed by the 2 weeks of the field practicum, and the 80% score, passing score, is required for the learner, for them to be eligible to join the second field, 2 weeks of the field. And the learner have chance 3 times to do the examination to pass to achieve 80%. And from our tracking, we found that most of the learner or the student, they can complete and they can pass each module within the like a single trial, and all of them can complete within the second trial. And that also happened with the module 2, which is the we would like them to have the like a principle or the fundamental of the tool that they're supposed to use for the risk detection or health risk detection analysis at the community level. We also see that before they have very low, like a certain level of the understanding about risk detection, and they know some about the tool that used for the detection and analysis. And this knowledge can be improved after the learning, right? Also, for the last one about the how to decide the intervention, how to address the problem at the community, we also see the improvement of this knowledge. And when we take a look like a summary of the course, right? So here show that when we analyze, we see the in terms of the statistic, like there is a very significant improvement of the knowledge of the student who like participate in the e-learning, 3 modules of the e-learning. And this thing, right, maybe have been it's happened because we have the one thing is we have continuous improvement. We always assess and then improve the content and also the teaching strategy to support, to more supportive for the understanding or the knowledge of the achievement of the learner. And so the impact. So let me share you that from 6 batch of the Tohun Ely implementation, right? The impact of the virtual learning, right? One thing we know that the e-learning, the learner can learn anywhere and learn anytime. So it means that the platform allows the learner to reinforce their knowledge, can read, can listen several times, right? By repetitive, like listening and rereading, right? That many times that they want anywhere if they have the internet. And so if we put this e-learning at the part of the blended platform, like a Tohun Ely, like that, the facilitator or instructor, right, it's very helpful for us, right? No need to tell them again what are the principles of the thing that they're supposed to do. They can perform. If you have the demonstration for some tool and some technique, when we ask the learner to review that, they can perform exactly that based on the video that they or demonstration that they experience with. And also we know that the e-learning or the online like a content can increase the accessibility of the learner to the knowledge and educating material. And also, right, using the e-learning can save the money for sure and save time for the instructor to teach also, right? And so, and during the COVID-19, Tohun also support for our member to develop some like online platform. And this online platform, they call a web-based application for the management of the COVID-19. From this one, right, we can see the impact of the online like a platform that is gonna be help us to do the health public health implementation faster. And also when we handle with something that very have the security concern. So we call this as contactless implementation. It's going to be more safe to use this kind of the web-based application instead of go to on-site and to get the information and go back. Right? I already mentioned that we have very good things, right, of the e-learning or the online platform. And when we look at the skill that we have to equip with and we need to reskill in the next 5 years, take a look at this. When we talk about skill, not the knowledge, right, or even the skill that are need for us to survive in the disruptive world, right? How this skill can be strengthened to the online platform, right? If you are the educator, you might familiar with this pyramid that we call pyramid of learning, right? And most of the technique and the teaching strategy that used in the e-learning allow the learner to read, to listen, to see the audio or visualization. And maybe they have some chance to do something, to respond, to comment, to use their system thinking to answer something, to respond to the question or some assignment that deposit in the system. But the e-learning cannot provide the participatory or interactive teaching method to the learner. Yes, if we have the Zoom meeting or some online meeting platform, it allows us to do the the student to do the group discussion, so they can apply the knowledge that they have to address a case or some scenario, or it's impossible for them to do a practice by doing, right? For example, if we would like them to detect something, it's impossible that they're gonna do online, right? Or maybe they cannot even train other a peer-to-peer training or education like that. And so what are the point? The skill, motor skill that I showed you before are not strengthened through pure e-learning, but through the participative and experiential learning activity like this one. If you would like them to have the skill on the risk detection, you need to bring them to do the risk detection, right? And also bring them to the field, to the community, to do something, to see the real situation, and ask them to do some capstone project-based learning or do some project that relate to that. So this thing gonna allow them to apply the knowledge to address the community issue or do something that relate with their job, right? Thailand, we have the village health volunteer, 1.5 million of the village health volunteer. How we train the village health volunteer? Because they are the ground people, they are the villager. We need to train them based on their job or their job description, right? What they are doing. We need to train them using the job that they have to advocate the villager or the community on health issue. So we need to train them how to do it properly, right? And use the technology or the tool that are feasible for them to apply, and also accessible by the community too. Right here, the example of the on-job training of the people, or for the high level, it's impossible to do online or to the virtual community. It need to do on-site, something that we need like a outbreak response capability or skill, we need to do the simulation, right? And here the sample that of the, and if we, during the COVID-19 pandemic, we really want to, we have to train the student or the learner, right? And how we do that? The teacher or the facilitator have to think hard how to balance between the one thing is the knowledge or the competency, the skill that the learner have to achieve. Another one, how the feasibility to do that training or educating, right? And so because of safety concern, we need to do online. And how to do that online properly? And I mentioned already, peer e-learning is not fit with or not feasible for the skill development. So some people think about branded learning platform, and this branded like a complies both asynchronous, asynchronous like a e-learning content like that. Synchronous is some activity that allow the student to interact and to improve the skill or the knowledge continuously, right? For the blended, these two components, not only the e-learning, but also some interactive learning activity are crucial for to incorporate in. So to do that, it needs planning and the skill design of the platform, like the learner or facilitator have to do this. When Tohun would like to develop the blended, one thing that we have to do is use the tool that we would like to apply. They call Graduate How is good. We go to use that and test first that is feasible for us to do or not. And then we can apply for the learner later on, right? And also there are several like application or tool, online tool that we need to select when we talk about online development, like branded development. People say that just put it online or just use the application. There are many of the application available. Which one they're going to be popular, right? So we need to customize, we need to select that carefully and to see the one that align with the learner, expected outcome of the learner and also the level of the learner also, right? Or sometimes we need to use the game, right? To to train the student to simulate something, right? If we cannot use like fields that I mentioned before, maybe we need the game-based learning or simulation to the game. They call gamifying, right? So use this like to enhance the high level of the skill to respond to something, right? So it's more fun and also takes time to do that. So come to the last PowerPoint presentation. When gonna be the challenge, right? I talked about success, the limitation of the e-learning or the virtual community of practice already. I would like to share that during the COVID-19 pandemic, Tohun Ili would like to, in year 2021, we would like to do the on-site, right? Because Tohun Ili has both e-learning and 2-week field practicum, right? We would like to do that. But the granting agency said that because of the safety concern, we could not allow you, right, to bring the participant to the community. And then what we're supposed to do, we need to develop the branded course very quick, right? And then once we have the branded course already. We did the survey with our participants, right, who passed the e-learning course already, right, and asked them, now we would like to replace the field practicum with the well-designed and branded training model, right? You still have the chance to practice something that you're supposed to do in the field, right? However, so 27 out of 29 participants, the response said, I don't want to join this branded training platform. The reason is that they said that despite of the well-designed, I believe that virtual activity could neither against my experience, skill, or the how I make the friendship with my friend, how I interact with the friend, like at the field practicum. So this is the take-home message for everyone, educator who develop the online or the branded platform, that how we develop the e-learning or the online platform that can be engage the participant and also allows them to provide the environment that are supportive for them to learn like a real world situation. And another one also achieve the outcome that we would like the learner to achieve. Those are the big challenge. I don't know for other, but for me, yes, it's a big challenge for everyone, every educator to think about. That is like all of my presentation today.
Well, thank you very much for your speech, Dr. Sangduen Monsoon. It is pretty much comprehensive on telling us about technology, which is blended learning or whatever. Okay, and this is for educating the society, in particular for the society of Thailand. Okay. Also, you said that it is pretty much challenging just because 27 out of 29 participants are rejecting your offer for studying with blended learning. Well, it's pretty much challenging anyway. Questions? Actually, we will put it in at the end of the plenary session anyway, so just keep it in mind. And thank you very much, Dr. Monsoon, again. And we would like to invite for the second speaker here. It's already in front of you. It is Dr. Toyoma Kataoka from Japan. Ohayo gozaimasu. Dr. Tomoya, I'm sorry for this. And a little bit about Dr. Tomoya. Okay, Dr. Tomoya is the Associate Professor in Department of Civil and Environmental Engineering at Hina University. He got master's degree and also Doctor of Engineering from Toyohashi University of Technology, Japan. And his research interests are in plastic pollution, numerical modeling, ocean surface radar, image processing, and artificial intelligence. And Dr. Kataoka brings us to the issue of microplastic contamination in Japanese river basin, current and future remarks. Okay, time is yours.
Thank you, Chair.
Okay.
So thank you for good morning, everyone. So thank you for inviting me to this great conference. My name is Tomoya Kataoka Tomoyakataoka, yes. So in university from Japan. So I'd like to talk about microplastic contamination in Japanese river basin. I'd like to tell you current and future remarks. So, okay. So first of all, I'd like to introduce the plastic pollution. So plastic pollution is plastics absorbing the toxic chemical in marine environment. So finally, plastics could be the threat of a marine ecosystem, severe impact on marine ecosystem. So, but in fact, this issue is not a recent issue. So, in fact, plastic particles were found in the Atlantic Ocean in 1970s. So, but researcher has not had little concern of this problem because impact on marine ecosystem is not clear. So, but important paper has been published in Science by Richard Thompson in 2004. So this paper demonstrated microplastics on the sediment around the UK coast. So they want the microplastics could be the threat of a marine ecosystem in the future. So after that, the many researchers has started the microplastic contamination in the marine environment. And on the other hand, research on freshwater microplastic studies has accelerated since 2013 because plastics source of plastics is around. So we have to investigate the plastic contamination in fresh waters. So on the other, is the same similarly. So and then plastic emission from land be estimated by several research. So today, I'd like to introduce the several major three estimates of a plastic emission from land to introduce our motivation of our research. Okay, so there are three major estimates of plastic emission. This is the first guess of plastic waste emission published in Science. So this research demonstrates the plastic emission from 192 coastal countries in 2010, 4.8 to 12.7 million metric tons entering Japan, entering the ocean. So plastic emission by 2025 will increase by a order of magnitude like this. So this estimation is a significant impact on plastic pollution. So, but several issues, several technical issues in the estimation. So they focus on the population living with 50 kilometers of global coast, but the plastic waste has been transported from inland to the ocean. So we have to consider the hydrological process from inland to the ocean. So they consider this process just conversion rates of a mismanaged plastic waste to marine debris, just 3 conversion rates to understand to estimate the uncertainty. Okay. So 2017, Reverton et al. Consider the hydrological process to transport the plastic debris from inland to the ocean. So they estimate the plastic waste at 1.15 to 2.41 million metric tons plastic waste. In addition, they demonstrate the seasonal variation and the hotspot of plastic emission. So he said, they said top 20 polluting rivers mostly located in Asia, right? Right this. So this shows the methodology by Reverton et al. They use waste management data, which is the same with Jambeck et al. 2015. But they consider the global dam database and flow direction and the catchment boundary derived by the topography. Okay? And they use monthly runoff data derived by precipitation. Okay? So using this data, they estimate the plastic emission from Iran by this formation. This formation. Okay. So next, this is a third research. Schmidt et al. Estimates plus emission 0.47 to 2.75 million metric ton. They also demonstrate 10 top-ranked river transport about 90% of the global emission. So they also use the plastic waste management data, and they calculate the catchment population using the population data and the hydrologic data. There is the catchment, the boundary. Okay, so by using this data, they calculate initial plastic emission. They estimate initial plastic emission. So from this data, and then so they calibrate initial emission using observed plastic waste data in the environment. Okay. Based on the regulation analysis, right? Okay, so this is the comparison among 3 estimates. So I told you total global emission like this. So I extract the plastic emission from Japan and Indonesia. So please focus on the difference among the estimates. So the estimates from Japan and Indonesia greatly differ among these estimates. Like this. So we needed to improve and validate these estimates based on our data in each country. Okay. So this is the motivation of our research. Okay. Okay. So we have started the microplastic research in Japanese river in 2015. So far, I have conducted a microplastic survey at 90 sites in 70 Japanese sites, Japanese rivers. So by using the plankton net with size of a river net mouth is 30 centimeters. So the flow meter attached the mouth of the net to measure the filtered water volume. So we hung the net from the bridge like this. It's not that he catches a fish. It's not that he catches a fish. He corrects the microplastics using this net. Okay, yeah. So this his pose is very good. Yeah. Okay, so this is a movie when sampling a microplastic from bridge. So okay. Okay. So like this, we correct the microplastics, and after putting up the net. So if in dirty river, the natural material attached on the surface of the net, like this. Okay. So we have to, after going back at the laboratory, we have to remove the natural material to pick up the plastics. So we have to conduct a processing to remove the natural material. So like this. So after that, we pick up the microplastic candidate by a human eye, okay, using the tweezer. And then we measure the microplastic size and using the stereo microscope, and we measure the microplastic weight using the ultra micro balance. Finally, I identify the polymer type by FTIR. So this laboratory analysis is very time consuming. Yeah. Okay. So this is a result microplastic distribution in Japanese river, right? Is so the mean microplastic concentration is 4 particles cubic meter. Please remember this value to discuss after that. So as you can see here, so background gradation in the background means population density. So in high population density, microplastic concentrated in the river like this, such as Tokyo and Nagoya and Osaka. In this city, are big city in Japan. Okay? So to investigate the relationship between the microplastic concentration and the population density and the urban area ratio, so we found a significant relationship these microplastics of microplastic concentration with the population density and the urban area ratio like this. And the microplastic concentration is higher. We found high concentration in dirty river like this. So the lateral axis means water quality class. This defined by the Ministry of Environment in Japan. Okay. Yeah. So by using this data and GIS data set, there is a population density and urban area ratio. So we estimate the microplastic concentration at a 1 kilometer grid to estimate the plastic emission from Japan. So in addition, we consider the macroplastics means plastics greater than 5 millimeters. Okay. So we use this data set to estimate. We use this data set to estimate the plastic emission from Japan. In addition, we analyze the water balance. So annually, water balance determined by the precipitation and the runoff and infiltration and the evaporation. So to calculate the outflow of land-based water, so we subtract evaporation from the precipitation in annually. So we calculate the outflow of land-based water and the microplastics and the macroplastic concentration. We evaluate the plastic emission from Japan. So this is a map of plastic emission from Japan. So expectedly, the higher plastic emission from Tokyo and Nagoya and Osaka, that is a big city, like this. So, there is no significant difference among these models. So by summarizing each group, the plastic emission at each grid, we estimate annual plastic emission from land is like this. So this value was consistent with Leverton et al. 2017. Okay. So, but there are several technical issues in this current estimate. So that is the current estimate don't contain the effect of the temperature change by flooding and existence of a microplastic smaller than 1 millimeter. So, to answer to resolve this issue, we have conducted a microplastic survey in flood condition at the Noda Bridge over Edo River and in the Chiba Prefecture near Tokyo. Tokyo is here. So this picture is Noda Bridge in normal condition. And in flood condition is like this. So we correct the microplastics in this condition at the 2 events. September 2017 and October 2017. So this is a temporary variation of microplastic concentration in the flood. So black line is a river discharge, like this, and this is a small event, and this is a large event. So as you can see this video, so in common, the peak of microplastic concentration appear in the rising stage of river discharge. Right, this blue area is a rising stage. So we found a peak of a microplastic concentration like this. So the peak of a number concentration showing the blue. So 1 to 1 order, up to 1 order of magnitude greater than normal condition. And the peak of a mass concentration showing the red dot up to 2 order of magnitude greater than normal condition. Yeah, it's the flooding is has a very impact of a plastic transport to the ocean. So this is the relationship microplastic concentration and the river discharge like this. And so microplastic concentration increase according to the river discharge like this. So in normal condition, the plastic concentration in summer is greater than our winter. We also found the seasonal variation of microplastic concentration like this. This one. Yeah. Next, we investigate the existence of a microplastics smaller than 1 millimeter. So this is a size distribution of a microplastics collecting by using the plankton nets. So please see this distribution. So 1 millimeter line is here. So microplastic smaller than 1 millimeter is the ratio of smaller microplastics decrease right here. So, but I expect the the smaller microplastics is the more the number of microplastics. Smaller the size of microplastics is the more the number of microplastics is I expected. But the number of microplastics smaller than 1 millimeter decrease. This because depending on the net mesh size. So please show this figure. So we use a 0.3 millimeter net, millimeter mesh size net. In this case, we can get microplastics greater than 1 millimeter. So, but the concentration of microplastics smaller than 1 millimeter could be underestimated because microplastic passing through the net. Yeah. So we arise the question. So how many SMPs? SMP means the microplastic smaller than 1 millimeters. So how many SMPs are in Japanese river? So to answer this question, so we microplastic SMP in Shigenobu River Basin at 10 sites like this. So 4 sites is in mainstream, and 6 sites is a tributary like this. So we collect the sample water at each site about 3 liters like this. And we repeatedly conducted this sampling at 3 times to reduce the uncertainty. Okay, this shows the laboratory analysis for SMP. There's a difference from the laboratory analysis for LMP. So, but basic flow is the same. So, firstly, we conducted the pre-processing to remove the natural material. And then we identify the polymer type by using the micro-FTIR to identify polymer type of the smaller microplastics. So normal FTIR cannot identify microplastics smaller than about 0.3 millimeter. So if we want to identify smaller microplastics, so we have to use micro FTIR. Yeah. Okay, this is the results. So the special distribution of SMP concentration in the rivers So we found 2 particles per liter, 2 particles per liter in the rivers. Please remember the plastic concentration in Japanese river in average 4 particles cubic meter. So we found that this the microplastic concentration of small SMPs 3 orders of magnitude greater than the that of LMP. It's very heavy. We found heavy contamination in Japanese river. The smaller size of a plastic particle was more the number of plastic particles like this. As a result, we found SMP is about 80% in 3 liters of sampling water. Okay, this is the conclusion. So we have to estimate the plastic emission from Japan. So we have conducted a microplastic survey in Japanese river, multiple Japanese river. So this motivation is it could be necessary to validate the current estimate of global plastic emission in each country. So as a result, plastic emission from Japan was roughly consistent with Lebanon estimate, one of the major global major estimates of global plastic emission. But there are 2 technical issues with the current. So plastic concentration in flat condition is not considered. And second, SNP contamination in water is not considered. So we have conducted additional survey. So based on this survey, microplastic concentration rapidly increased according to increase of growth. And we found heavy contamination of SMP in Saginaw River Basin. Based on these results, we conclude the current estimate could have been underestimated. So it is necessary to consider the increase of a microplastic concentration during the flood and the SMP contamination to the current estimate. Okay. So if you are interested in our research, please contact me. Okay. This this research have been collaborated with Yasuni, Professor Yasuni of Tokyo University of Science, and this research supported by several funding like this. Okay, thank you for your attention. Terima kasih.
Yeah, thank you very much, Dr. Tomoya. It is also another interesting topics. Just because I have also questions, but I should be consistent with my statement. Just I will put these questions at the end of the plenary session anyway, and then put priority 2 questions coming from the audience instead of mine. Thank you again, Dr. Tomoya. And the last speaker, this is the 3rd speaker, is Professor Hadianto. Selamat pagi, Mas. Okay. And a brief about him. Okay, Professor Hadianto works as a lecturer in Department of Chemical Engineering, Diponegoro University. And now he is also served as Vice Dean for Academic and Student Affairs of Postgraduate Studies. He got master degree in 2003 and Doctor of Philosophy in 2007 from Wageningen University, the Netherlands. Okay, about research focuses are input processing, bioprocessing, microalgae, environment, and bioenergy. Professor Hadianto spots on how to harness energy from microalgae. Okay, time is yours, Professor.
Thank you very much, Pak Agung. First of all, I would like to thank to the committee for inviting me to presentation to this event. I would like also to thank Dr. Tomoya. He's actually our counterpart for the collaboration for research. Starting last year, we wrote a proposal about microplastic. Since microplastic is still popular issue right now, and we proposed to GSPS, but unfortunately it was not successful. But we will try again this year and after next year to get the research funding, and we will have a collaboration on this area. Since the first day and also today, all the speaker already cover the topic in this Icenis, including environmental sciences, Prof. Peter yesterday, and information system, Prof. Nur yesterday, and Dr. Tomoya, so in environmental sciences, epidemiology, Prof. Alfonso, and so from Dr. Mosum, and I will be presenting about the energy sections. And today I would like to give a presentation about harnessing energy from microalgae biomass. I will not look at into detail about the biological aspect, but look at into process engineering. I would like to start the presentation with the questions what happened to Indonesia, especially after 50 years, since the government always said the fossil oil will be depleted after 10 or 15 years, but it was says 10 years ago. Always say 10 or 20 years from now, the fossil oil will be depleted. Then we have to search alternative energy to replace this fossil oil. One of the important or one of abundant sources that may be possible to be used as a alternative energy is biomass. We know that Indonesia is an agricultural country, meaning that the source of is very and if we talk about the biomass energy, actually we look at 1925, in which Mr. Diesel in that time converting directly the oil into or becomes fuel to run the cycle. We call it as a diesel. And the research going on, searching to replace this oil, vegetative oil, because if we use vegetation oil like a corn or maybe also here soybean, then we will compete to food security. This category for this biomass, we call it as the first type of biomass, and then we look for another alternative. We call it as the second generation of biomass. In this slide, for the second generation, normally it come from the wood, and also from grass, and then it comes to the problem again. How about the area? How about the agricultural land that may be used for to generate this biomass? And the third generations will overcome this problem, in which we will not compete to the land area and also to the food security. One of the sources for the third generation is microalgae. You know, the microalgae is cultivated under photosynthetic reaction to convert carbon dioxide into biomass. To convert carbon sources into biomass using these reactions, CO2, and then the microalgae will be fed up with the nutrient and also under photosynthetic, meaning required light, and then to convert into biomass. And as chemical engineering or process engineers, so we look at what we can do with this kind of biomass. This one. With the infrared. Yeah. Hi. Yeah. So what we can do with this biomass? The biomass is actually consists of carbon sources and then hydrogen, nitrogen, and also phosphorus. Actually, we also have another trace elements in this biomass, including sulfur and also some trace elements. Yeah. Okay, this is the principles of growing the microalgae. At least, if you want to get the biomass, we have to provide this feedstock like carbon sources and also nutrients and also light. That's the principle to cultivate the microalgae. And the growth factors that can be used to cultivate this microalgae, we have also yeah. So the growth factor for microalgae cultivations, we have nutrition factors, including carbon sources and some nitrogen sources, yeah, and some mineral and also trace elements. And we need light as well to run the photosynthesis methods. So we have sunlight, or maybe if you cultivate the microalgae under or in the lab, you use LED or some light. And then we have processing parameters, including some mixing, yeah, you need the mixing and you need the light requirements in this case, and some environmental factors, including pH, temperature, yeah, and also some salinity. Depend on the microalgae type, whether the microalgae is coming from the high salinity or from fresh water, the salinity will be adjusted to the environments. So we look at the biomass of microalgae. Actually, the microalgae itself can be competitive compared to human food right now. If we look at this is a microalgae in the square. For instance, chlorella, it has protein 51 to 58%, and also carbohydrate 12 to 70%, and the lipid 14 and 22%. It is comparable to the common other product like a milk, also meat, yeah, and also rice that has protein around 26, and then carbohydrate 38, and the lipid maximum 34. So from this composition, we can see that microalgae is also potential to replace this product. Thank you. Yeah, and one other application for this microalgae, maybe some of you already know where we can find microalgae product. If you go to the apotheke or other shop, you can ask for the protein in the capsule. Normally, they will give you spirulina. Spirulina is one of the algae that has 70% of protein, so can be used for food supplement. So to replace food and also feed, yeah, and then health food, therapy, pigment is also potential because microalgae also has a nice color, blue color, what we call it as a phycocyanin. This one, yes. Phycocyanin is very nice color, normally used in textile company and also for food colorants. It can be extracted from a microalgae. And then what we want to focus today, that microalgae also have long chain hydrocarbon that is possible to be used for energy. And again, this is the processing route for the microalgae cultivations. If we know the source, and then we can do isolation, and then we make a scale up in the laboratory and then put in the reactor. And then as we know from the previous slide, to cultivate the microalgae, you need a nutrient, also you need a carbon source and also water. And after some period, the concentration will be high and we can do harvesting, yeah, harvesting. And then for harvesting, we can further process using extraction, fermentation, or anaerobic conversion, catalytic conversion, depending on the product that you want to have. For instance, if you want to have hydrogen, then the biomass of algae is processed under anaerobic conversion. If you want to have bioethanol, then you have to do fermentation in order to get this product. Okay. And what about the bioreactor that we use? Normally in industrial scale, the microalgae is cultivated under two type of photobioreactor. The first one, what we call it a photobioreactor. Photobioreactor is a reactor that using closed system. There is no contact with air, and so the microalgae itself. Yeah, and the second method is in open pond, or we call it as raceway. Yeah, raceway. This is also popular to get biomass in scale commercially. Yeah, for this type of bioreactor. Yeah, but for those two type of photobioreactor, there are pro and cons. Yeah, for instance, for the photobioreactor, the productivity is very high as compared to open pond. Why? Because in photobioreactor, normally they are controlled. The pH, temperature, and salinity, they are controlled. Yeah, but for open pond, normally they less controlled. Yeah, meaning the productivity for open pond is less than photobioreactor. Another disadvantage of photobioreactor is there is contamination. Contamination for open pond because the system is open, and then the contact between air and also the microalgae is large, so the potential to have contamination will be high. And for water losses, of course, the open pond is because it's contact directly to the sunlight, and then the evaporation will be high as compared to photobioreactor. But of course, because the industry require large product, then open pond is currently is more preferable for industry rather than bioreactor. Oh. Yeah, in order to get biomass of microalgae, we have to do some harvesting. It is the difficult part because the size of microalgae is very small, less than 200 micrometers. We need some kind of method in order to get biomass. If you look at the microalgae, for example, just take culture of microalgae and then look at it's just only water with a green color. We cannot see what is the size physically by our eyes. So in order to get a biomass, we can do some harvesting method. We can do some flocculations. It means we can add some flocculant in order to make a block of this biomass. And also we can have filtration using membrane. Of course, membranes will make a cost high. Yeah, the filtrations. Normal filtration will not possible. That's why we can use membrane. And then we can have flotation as well and sonication using ultrasound harvesting. It is also possible. Yeah, and also some centrifugation and precipitation. So depending on the size of microalgae, those harvesting method you can select. For spirulina itself, the size is more than 200 micrometers, so you can use just use a normal filter. Yeah. Okay, this is the main topic for this presentation. So how we can convert algae cell to the energy. The algae biomass we can convert to energy, yeah, based on some processes here. For instance, if you want to have a bioelectricity, then we have to use microbial fuel cells. And you want to have a bioethanol, you have to do fermentation. For biodiesel, you can do esterification, and then for bio uproot or jet fuel, you can use thermo processes. So depending on the main component of the biomass, yeah, for instance, one microalgae that has very large in carbohydrate, it is better to be converted into bioethanol. But if a microalgae has very high in oil, yeah, for instance, chlorella or Goitrococcus, then it is better to be converted into biodiesel. So first look at the type of microalgae and then identify what is the main content in this microalgae, and then what's the process that we are going to use. This comparison between microalgae and also some arable land, yeah. So for instance, this is the microalgae with the oil yield more than 58,000, yeah, liter oil per hectare per year, as compared to, for instance, sunflowers, it's only 1,070. And then compared to soybean, only 600. Means that the productivity of microalgae per hectare is much higher as compared to other higher plants, yeah, like this. And this is example of some microalgae using or we have identified. Yeah, for instance, Goitrococcus brownie, it can have oil content until 75% dry weight. And for Nanochloropsis, we have 30 till 68% of the oil dry weight. And for Phytotillum, we have 30%. So until now, the highest oil content in macroalgae belong to Goitrococcus brownie. Okay, this is the first application for bioenergy. It's biodiesel. So biodiesel actually the conversion of triglyceride into biodiesel, and the reaction is between TG or triglyceride with methanol under ratio of 1.3, 1 to 3 of triglyceride and also methanol. And the process can be done in two steps. First, esterification, and then the second is trans-esterification. Esterification because the free fatty acid in microalgae is very high, still high. Then it has to be reduced, yeah, in order to avoid saponification reaction. Then we do esterification first, and then after we get lower free fatty acid, then can be directly converted into biodiesel under trans-esterification reaction. You see here that algae biodiesel can be formed, and also some side product is glycerin. Just using centrifugal separation, then you will get algae biodiesel. There are some research that already done in this area, so algae for biodiesel. For instance, spirulina, his lipid content is 7.2, with total fatty acid is 60.2, which means very high for fatty acid. And then if we compare, convert it into biodiesel, it's only 2.11. So it means spirulina is not really potential to be converted into biodiesel. How about chlorella? Chlorella have lipid content is 57, and then the total fatty acid is 94. With biodiesel is about 59 till 71. So in this case, chlorella is much potential to be converted into biodiesel. Bioafter. Actually, the research utilizing microalgae for energy is already runs 10 or 20 years. Yeah. And in 2015, I believe, yeah, in 2005 or 2007, there was news, yeah, that KLM is airline from Netherlands and also in United States. They try to use algae fuel to run the flight. Using 5% of the composition of the after, they can fly 90-minute flight. So it is it means that algae oil is also possible to be used as after, yeah. But still in 2.5% trial. 2.5% trial. I don't know whether the flight has passenger or not, but there is no further information about this. So with 2.5%, the flight can run. Okay, the bioafter itself is already run for the research, and there is some research that already done in bioabsorbers from microalgae. And then for bioethanol, yeah, for bioethanol, there's also a possibility. There is some macroalgae, there are various algae that are possible to be used for bioethanol because the carbohydrate is very high, yeah, very high. So carbohydrate, protein, and lipid. Normally, we want to use ethanol. We select microalgae that high content of carbohydrate. With some example. So, for instance, in Chlamydomonas, the ethanol concentration that already produces 10.5 gram per liter. And then Dunaliella is 14%. How about the bioelectricity? Yeah, this is also one of our work in our research group, converting microalgae into bioelectricity. Whether it is possible or not, but we already done this, yeah, and make a small scale in our lab. We call it as microbial fuel cell because we use microalgae, then we just add the term of microalgae in front of microbial fuel cell. So we call it as microalgae microbial fuel cell. Why microalgae can be used in these fuel cells? Normally, microbial fuel cells consist only waste that in another side and also just water in cathode side. Anode consists of waste, yeah, and then after the degradation, the waste will form CO2, will form CO2, and also because of the degradations, some proton and also electron will be produced. If CO2 transfer from anode to cathode, and then the cathode you fill with the microalgae, we see the photosynthetic reactions that microalgae require carbon sources. Then actually we have a carbon sources from the waste water that already degrading. Yeah, CO2 is transferred to microalgae. Microalgae due to photosynthetic will produce oxygen. Oxygen actually is oxidator that can capture electron. So if you produce microalgae more and more, it means the oxygen will be high, and then the number of electrons that can be captured is also very high. Then because of transfer between electron and proton, and the electricity will be produced. Yeah, that's the basic principle of this fuel cell. And we also measuring here the dry biomass of the microalgae it's growth, and then the CO2 removal. It means the wastewater that can be degraded is also 70% can be degraded. Yeah. This our article that already published to measure or to see the potential of microalgae to generate the electricity. We measure the potential, also we measure the power output. Of course, the power is still very low, still in order of 14 milliwatt per square meters. Is still very low, but at least we have something here. Maybe in the future we can make a scale up, or we can do a parallel of this unit in order to multiply this power that we already achieved. Okay, and then algae, because it has capability to absorb carbons, yeah. Then why we don't use this microalgae to purify the biogas or to purify the CO2 from the flue gas? So this idea is coming from the flue gas has 20% of CO2. If you want to reduce the CO2, normally we can use water, yeah, in absorber, or using chemical agents, yeah, monoethanolamine. But those methods will have the disadvantage because of the pollution, water pollution. And then we can use algae, because algae required carbon sources, and flue gas has 20% CO2, meaning that we have a free CO2 to feed microalgae. We run some experiment, and it successfully absorbs CO2 in flue gas, yeah, CO2 and also NO and SOX. We can see here that algae is still growing while it also absorb CO2 and also reduce SOX and also N. And then upgrading biogas. Yeah, biogas contains 40% of CO2. Due to this high CO2 content, then the caloric value of biogas will be low. Yeah, will be low. That's why we have to think how to reduce the CO2 content in biogas. And then again, we can use a microalgae. Yeah, we just put biogas in the microalgae reactor, and then microalgae will absorb the CO2, and then biogas will go through the culture, and then we can catch again the biogas. Finally, we have biogas with high caloric value. Yeah, hydrogen from algae is also possible. Yeah, this is integration process because we want to produce energy, but also you want to treat the environment. Yeah, for instance, if you want to have microalgae and then combining with the treatment of wastewater, and also you want to produce another product other than energy. For instance, we want to have fertilizer, we want to have food, we want to have wastewater treatment here. That's also possible. We call it this as integrated process. The example of this is by using palm oil milk effluent. Palm oil milk effluent is effluent that's coming from palm oil industry. Yeah, and this is the characteristic. The characteristic of the palm oil milk effluent, it has a high biological oxygen demand, it's around 25,000, while COD is 50,000, and total solid 40,500, and suspended solid 18,000. Of course, this is a very dangerous to the environment if we throw directly to the water body. That's why we have to think microalgae technology, how we can use this palm oil milk effluent as a source of nutrient. Because you see here that beside of this waste characteristic, palm oil milk effluent also has a positive aspect. It's not nitrogen, it's 700 milligram per liter, and also phosphor 180, and some potassium is also very high. So this is we call it as nutrient for microalgae. Okay. Normally in palm oil industries, palm oil milk effluents is treated by using lagoon, anaerobic digestion like this. Yeah, they consist of 4 pond, first, second, and 3 and 4. Yeah, with different function in this case. And finally, the foaming out of the last pond consists of this one, but the COD and BOD are still high. Yeah, still high. So we have to recover some nutrient in this palm oil milk effluent, while COD also can be degraded. So this is our system. So if we have foaming, yeah, if we have foaming, and then put it in the biodigester, and then because the foaming has very high COD, if you cover up the foaming, and you will have CO2 and methane, or if they combine, then we have a biogas. Yeah, we have biogas, and then the rest of the nutrient, or the rest of the waste water still have a high nutrient, nitrogen and also phosphor, and then put it into algae bioreactor, and then algae bioreactor can grow, yeah, can grow using this nutrient. What about CO2? CO2 can be gathered from biogas. We know biogas 40% of CO2. So totally in the system, we have free nutrient, and also we have free carbon sources. And another advantage, we have also microalgae biomass that can be further processed into product, can be food or feed, yeah, or can be energy. where the biogas can be directly transformed into energy, like electricity or for cooking, yeah, in the area of industry. So this is an integrated process that we applied in PTPN 7 in Lampung, and it was successful. So this area or site plan that we constructed, so in this open pond, yeah, that we constructed in Lampung, and finally we can get biomass of microalgae. In this case is spirulina. Because this is coming from wastewater, we will not use it for food, but we use it for feed for animals. Yeah. Okay, I think that's my last slide, and thank you very much for the. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much, Professor Adianto. It is always pretty much interesting issue talking about renewable energy or alternative energy. And moreover, the microalgae provides many forms of energy, for example, electricity, biodiesel, gasoline, and also jet fuel. So maybe you are flying over the world, later on will be supported or fueled by this microalgae. Okay, thank you very much for these three speakers. Okay, and let us give them big applause for the well-respected speakers. Thank you. And now we come into the question and answer session. And there's already questions, 3 questions from online. And now I also open question from this audience. Okay, anyone? Question? Okay, one. Only one? Okay, yeah. Please raise the questions. You have the microphone? No? Okay, please give him the microphone. All right, good. Okay, state the name, your institution, and the questions.
Yeah.
Thank
you. My name is Andika from Environmental Science Diponegoro University. And my question for Mr. Tomoya. We have mapped and measured the concentration of microplastic in river and sea. And the next further step is to measure the concentration of microplastic in organisms like plankton, fish, and other aquatic organisms. And my question is there any research or data about the concentration of microplastic in organisms in Japanese sea or river? And the second, is there any remediation or bioremediation technology to reduce concentration of microplastic in Japanese sea or river? And to Mr. Hadianto, I just asked for the opinion. Microalgae consists of protein, carbohydrate, and lipid, especially polyunsaturated fatty acid. Is it better for food than for fuel? And the second, what is the most suitable generation of bioethanol production or renewable feedstock which can be implemented in Indonesia? What's your opinion? Thank you.
Okay, thank you. Any other person to ask for raising questions? No? All right. Okay, Dr. Tomoya. Okay. Please answer the question. There are 2 questions for you. Research concentration in Japanese Sea, they're available or not, and also how to remediate this.
Okay, thank you for question. So our first question is to be better, which estimates of several estimates, right, of plastic global emission, right? So I think the current estimate by Leverton as well, 2017, is better than other estimates because they considered hydrological process and they consider they contain the monthly runoff data derived by the precipitation in their estimates. So plastics is transported due to the runoff of rainwaters. So they consider this process in their estimates. Yeah, this is the answer of your question, right?
Is there any research data concentration of microplastic in fish or other organism in Japanese Sea?
Oh, Japanese Sea?
In the sea.
In the sea,
In the
in the sea, in the river or in the sea?
Oh yeah, Japanese Sea. The plastic concentration in the Japanese Sea is very higher, higher than average of world concentration in the sea. Yeah. So
And-
because the microplastic concentration, microplastics are transported due to the ocean current around Japan. There's two big ocean currents, so Kuroshio and the Tsushima warm currents. So microplastics are transported to from Asia country to Japanese Sea. So some of microplastics in the sea probably microplastics are transported to the ocean from inland. Yeah. So I have no answer. The contribution of plastic road of Japanese from a Japanese river greater than other country. So I have to investigate. We need more research to investigate the plastic products from Japanese land or microplastic proteins from other countries, other Asian countries. So we have to compare between these amounts. Okay. Is it answer?
Okay. The impact of microplastic in organism is not your research.
Yeah, not really.
Okay.
Yeah.
And is there any remediation technology to reduce concentration in river on the sea in Japan?
Sorry.
Is there any
what to do with this problem to address this problem? What to do Japan?
Oh. Yeah. Oh yeah. Not yet. Yeah. So we will we would like to investigate the plastic contamination in Java City, Java Island, so in Indonesia. So we can we achieve this project with collaborating with him.
Yes, yes, okay.
Okay, thank you.
Thank you, thank you.
So we have potentials Indonesian. You also for joining the project.
Okay, yes.
Yeah, I'm welcome.
Okay, thank you, thank you.
Professor Hadianto, next question from the same question.
Yeah, I will add briefly about what we can do to remove the microplastic. Currently, our group is also running a project to remove the microplastic in aquatic system. First, by using microalgae, because microalgae under stress condition, it will produce exopolysaccharide that sticky. And then we will use exopolysaccharide to attach the microplastic, and finally we generate agglomeration, make a block, and then we just make a filter of it. Just one method of using microalgae to remove microplastic that still under research in our lab. And maybe we will write proposal with Dr. Promoya about that as well. And then about the questions, which one is better between food or fuel using microalgae? Right? Yeah. So far, food or feed is more preferable rather than fuel. Because economically it's not feasible yet. Microalgae convert into energy, especially you want to convert from water to fuel. It's required costs and so some energy. So the preferable right now use this microalgae for food or for feed. That maybe somehow in the future we can do much better in this energy research from microalgae. And then the second question is about the feedstock, right? The feedstock for bioethanol. As long as you have cellulose, lignocellulose feedstock, then you can convert it into bioethanol. So far, maybe for the small industry in the rural area, they use tetes. You know tetes. Tetes is the rest from tebu, from sugarcane, for sugarcane processing. Because it can be directly fermented into bioethanol. But if you use lignocellulose, you will need additional step. You have to hydrolyze first for this lignocellulose into sugar, and then sugar fermented into bioethanol. Yeah, but so far the problem in Indonesia to get these energy products is the amount of feedstock that available in the area. And that's why we also thinking to use multi feedstock, which means all the feedstock that, although the amount is small or amount is less, they combine all together and then to see whether the bioethanol can be produced or not. Of course, need further research for this.
Okay, thank you.
Okay, I think you got the point of this of your questions answered. Okay, let's go to the online questions. Can you please show the questions? It is from Mauricio de Castello. Okay, to Dr. Sangdun. I would like to ask about application e-learning by mobile application. Some applications now are available on Play Store and complete, with diagnostic and treatment. And sometimes the learners are not medical doctor, has a background of medical doctor, is comparable to apply. If is confinable, how about medical doctor in the future? Do you got the questions, Dr. Sanggun?
Yes, I
Okay.
think that I already respond to the chat already. Some I just restate that. Yes, now the platform, right, is what we call is compatible to the mobile visualization, right? And Tobun also would like to integrate this in the what we call for the commercials or the private companies, like a Play Store or something, right? For to broaden the audience and also the reader or the learner from that one. And I think that is also connect to the another question also and concern about the people who develop the online, right? So as I mentioned, this e-learning is developed by multidisciplinary experts. If the content that's about the medical doctor or medicine or medical technology, and medical technologies, licensed medical technologies also, and so it needs to review and approve to ensure, right, to meet the standard of each like a professional. First, that is a one thing. I'm not sure for other, but the good practice is when you develop the e-learning for multidisciplinary learner, you need to ensure that the content and the standard need to meet each profession, standard of each profession. And if you remember the first few slides that I introduced about Tobun, there all the activity or the content need to check alignment with, for the medical doctor is the IHR, International Health Regulation, and for the veterinarian we call veterinarian public we PVS, right, at some standard. And also I think that the environmental side also have some standard that we need to align with. When we develop that, for especially for the Tobun e, all the content have to be developed and reviewed and approved by the content expert in each discipline first, to ensure that when they graduate, they're gonna get the accurate knowledge. And also when some of the non-health side to study, they will get the right content and also the right knowledge for them to follow also. I think that is a first question that I would like to answer.
Okay, so that's the answer. Thank you very much, Dr. Sanggun, for your answer. And for the next questions, please, from online. Yeah, we have 3 questions. This is the second question from online. From Sunday Kerkula. Same, it is addressed to Dr. Monsoon. My main concern is wrong application of these e-learning training models, where a non-medical doctor might complete the model and then takes him or herself as a medical practitioner. He goes on confidently practicing medicines, known fully well that he is not, but because of the e-learning training. Well, this is the side effect, maybe. This is too confident person, I think. What becomes the future of medicines if e-learning training models are considered? Okay, for the second question, it is addressed to Professor Hadianto. Are the oils extraction produces the same for algae, vegetable oil, and fats? If different, what are the methods, side effect, and additional source of income for extractor? Well, the first question will be answered by Dr. Sangdun. Please, Dr. Sangdun.
I think that the second question is still aligned with the answer that I answered before, right? What happened with that? And another level to ensure that when we develop the course that relate to some profession, it need to review or accredit by the like a society or some like a organization that standardize the knowledge or the skill in that discipline, right? So, for example, if Tohun would like to develop the course that gonna be strengthened skill of the environmental side or the public health expert, I think that need to be reviewed and approved by Ministry of Public Health or a Ministry of Natural Resource of Thailand or some society, right? In terms of the medical, we have the Society of Medical Medicines here in Thailand. It needs to be approved by that to ensure that once you pass that e-learning, you're gonna get the not only the accurate but also standardized one or reference source of the knowledge, right? So that is another level. And I think that for the non-health side, right, non-health side, before non-health side, I would like to mention that at the e-learning, so because e-learning focus on the knowledge advocacy and none of the skill can be strengthened, fully strengthened to that, right? So that's why it's only the process to review and to ensure that the accuracy of the knowledge going to be accurate enough or aligned with standard in the field or not. That is one thing, right? And to be the skill of professional in each discipline, I think that it need not only the e-learning, right? You cannot be the professional only by attend of the e-learning skill. You need to go to the professional or the specific school, medical school, or to get the to be the skillful professional, like that, right? For non-medical doctor, right? Some e-learning like that are available for the skill. Most of the skill that we need for handle with the some like a challenge or survival or this are the soft skill. Most of soft skill is eligible for everyone to learn. No need to be the discipline, discipline, no limit of the discipline. Everyone have to have the chance, have the right to practice that, right? Because sometimes we call interpersonal skill, interdisciplinary skill, right? So that go to the answer that it's no problem for the non-health side to go for the part of the some content or some skill that not like a discipline based or technical based knowledge or skill, right? But for the technical one, it needs to go for the school. I think that there are many schools that offer that already. Yeah, I hope that the answer, my answer gonna respond to all questions in the online platform.
Thank you, Dr. Sandun. Yeah, that's the answer. I think we don't need to worry about the expertise of the technical issue for this situation. Well, for the second question, it is addressed to Professor Hadianto. Okay, you still remember the question? Okay.
Yeah, the question I think is whether the method of extracting oil from different vegetable oils are different or not. Actually, the method are just the same. Yeah, just the same, including the solvent and also the procedure is just the same. If he or she asks about the characteristic of the oil might be different. Yeah, might be different. In terms of free fatty acid, maybe algae oil has higher than soybean oil, yeah, and maybe lower than jatropha oil. Yeah, so the difference in the product itself, not in the process of extraction. Yeah, there are some research in the selection of the solvent to get high yield of the oil. That's different things, but the procedure is just the same. Yeah, and then the last question is about.
Okay, please show the questions again. Yeah. Okay. If different, what are the methods, side effect, and additional source of income?
Because my answer is the same, no different. So I don't need to answer the last, yeah, for the extractor. Yeah.
Yeah. Okay. So that's the same anyway. The method is the same, but the
oil characteristic are different.
Okay. Thank you, Professor Radianto. For the last question from online, from Professor Kusmiati, I would like to. Okay, this question is for Professor Radianto. How to extract the oil from algae? What is the method? What is the content of oil from algae? Thank you. And what is the percentage of still questions? Yeah, what is the percentage of oil extracted per kilogram algae? How it the economic point of view for the process to oil?
Yeah.
Okay, so the economy.
Yes, as I said before, that the extraction of oil from the algae just the same as the vegetable oil. Yeah, you can use ethanol. It's also a good solvent to extract the oil, or you can use hexane. Yeah, it's also possible. Yeah, it's possible to extract the oil. It's just the same. And about the content, yeah, the content of oil, as you see in our slide, the content of our oil are still low as compared to others. Yeah, the content, but the productivity itself of the biomass of algae is high. So far that we studied in our lab, the microalgae chlorella is about 20 or 30% of oil. So yes, still potent for the energy. Yeah, we have to look for another species for microalgae that has very high, for instance, Poitrococcus browni. And economically, if Prof. Kusmiati asks, yes, still not feasible right now to extract oil, yeah, from algae, because actually if we cultivate algae, its content only 10 or maybe 1 or 5% of solid. Yeah, the rest is just water. So that's the challenge in the cultivation of algae, how we can get high biomass, yeah, by spread this biomass from the water, yeah, because it's very dilute. Economically, if we counted one in economic perspective, then it will not possible. It's not feasible. Yeah.
No, it is not feasible, but maybe 2 or 5 years later there will be potential for harvesting economically. Okay, so we have already addressed for persons questions, and please check are there any other questions from online, and I will raise this question, the other questions. I mean for this persons here. Okay, anyone? Okay, thank you. Yes, please. The back one first. Okay.
Halo, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Hello, my name Ari Puji Winarko from Postgraduate School Diponegoro University.
Okay.
I have a question to Professor Sangdun and Prof. Hadianto.
Yeah.
Arun Sawat, Sawadikap, Prof. Sangdun. The first question is, in your presentation, you mentioned what 10 skill need to in 2025. But skill to overcome environmental impact not yet mentioned or not exist in your presentation. Actually, skill to overcome environmental impact include in with 10 skill you mentioned in your presentation. Of course, it's considered that in the future, negative environmental impact more biggest and more complex in the future. And environment, especially skill to addressing environmental impact, more important, I think yes. Number two, second is in the end of your conclusion, your presentation, you said that e-learning, I see that e-learning more effective and more likely by learner. Maybe it is true in the situation pandemic 19, but in the post-pandemic, maybe result will be different. How about this? Your opinion is maybe you can explain. Maybe that is question to Professor Sangdun and to Professor Hadianto. My question is, I have heard that B20 and now B30 from crude oil is more potential to biofuel. But in your presentation, but because political situation is undeveloped, especially in developed countries or in Europe. But in your presentation, you not mention it. Maybe you can explain which is more effective, that B20 or B30 from crude oil compare from algae. Maybe my question is.
Okay, Ali, thank you very much. The questions again, I think Professor Sangdun will answer the answer first. After that, Professor Hadianto will follow. Okay, Dr. Sangdun, please answer the question. You got the point, huh?
Yes. ขอบคุณค่ะ and สวัสดีค่ะ maybe this time is the maybe not Arun Sawat because we are nearly the mid of the day. You can use Sawati also. Thank you very much for your patience, and your Thai is very good in this conference. First of all, I think I cannot catch that. Please let me know that I hear correctly or not. You said that the one that disappear from the top 10 list is the outcome assessment or some impact assessment. I understand correctly or not?
Environmental impact to
okay.
Overcome environmental impact is more important, but not you mentioned in top 10 you need to in 2025. I mean, what's opinion, but it's considered that environmental impact in the future is very bigger and more complex. Maybe it's
yeah. To answer that, I mentioned these top 10 skill, right? That discovered or classified by the World World Health, our economic forum, like that. So it's based on the survey of the people, the expert around the world, right? And come up with that top skill. And I think that this skill, we talk about skill to do that, maybe it's count in one thing. Is a problem solving, critical thinking or something. And another is leadership one. So we need to go to in the detail, right? What because normally the leadership who have the leadership need to decide something, can have the urgency, know which one they're gonna have impact, right? And I think that the environmental impact assessment not disappear, because right now we have the climate change, and also the when we have the COVID-19, the what we call the most affecting thing from the COVID-19 is from the to the environment, and also from the environment to the COVID-19 itself also, and they are in the, I think, the top 5 list of the global risk in this world. No, it's not disappear, but maybe the skill maybe fall under some critical thinking development and problem solving development and leadership development, right? That is the one thing, right? The second thing you asked about the e-learning seem to be from the assessment, it seemed to be good for the knowledge advocacy of the learner during the COVID-19 pandemic, and for me, I think that you might be correct that the normal situation may be different, right? But I'm not sure that it's going to be more effective than this, or better than this, or lower than this, because when we have, it depends on the instructor who lecture also. Normally the knowledge gonna be delivered based by the lecture. It depends on the style also, and also the learner engagement. So that those are gonna be affect to the teaching and the result of the knowledge that the student or the learner is supposed to get, right? So maybe different, but I'm not sure. Depend on the delivery or teaching strategy of the individual instructor. Yeah.
Okay, thank you very much. I think you got the point of the answer. Yeah, Prof. Hadianto next.
Okay. Okay. The question is whether which one is better, P20 or P3? Yeah, P20 or P3. P20 meaning that the diesel, the current diesel consists of 20% of bio, yeah, and 30% meaning 30% of biodiesel. The problem actually first, the availability of the biodiesel in Indonesia is not that much. So whether 20 or 30%, it depends on the feedstock, of the availability of the biodiesel. And then if we look at the characteristic, for instance, comparison between P20 or P30, then if we go close to 100% of biodiesel, of course, the advantage of using biodiesel is good for environment, of course, yeah, and then it's reducing the pollution, yeah. SOx and also NOx will be less as compared to fossil diesel, yeah. But the problem is economically, yeah. The cost to produce biodiesel is still high. That's why maybe we still have P20 or P30. 100% is still costing.
I'm sorry, Mr. Hadianto. I mean, it's comparative from B20 or B20 to algae, not comparative B20 to B30, but
yes, yeah,
to algae products. Thank you.
algae is just one feedstock of biodiesel. So if we already got the biomass of algae and then convert it into biodiesel, and then you can just mix with the current fossil diesel. Either you can use P20 or P30. That's possible. Yeah, but again, we have to look at the economic point of view. Yeah, so we cannot. Yeah, maybe if your question is a P20 or P30 and compared to 100% and algae, then of course it will be a difference. Yeah, again, algae diesel is biodiesel, a pure biodiesel. Yeah, so P100 diesel, biodiesel. The characteristic properties of biodiesel is we can just read from the literature. Low pollution, then also degradable, yeah, and so on. But we face with some challenges, the availability and also the economic point of view. If we use algae diesel to replace the P20 or to use in P20 or P30, that's possible. Yeah, that's possible. But again, we have to look at the economical aspect.
Thank you very much for the answer, Dr. Sanggun and also Professor Hadianto. And I invite the questions from, okay, this person, please. Yeah. Okay, thank you. Are there any questions from online? Okay, please check. Yeah. Okay, please.
Okay, thank you for the time. My name is Sinan, and I have a question for Tomoya Sensei. Okay, as you can say that microplastic is the sources of microplastic is from land, rivers, and then into the ocean, right? But before to the rivers, also the first sources is from the land. So my question is, from where is the dominant sources of microplastic? Is maybe like from the factory waste or villagers waste that, as we know, Indonesian people know that Japan is one of the most cleanest country in the world. And the question is, how is possible that the one of the most country in the world have microplastic content? And then if you can see your presentation, the result of microplastic between Indonesia and Japan has a different result. That Indonesia have a significant result microplastic more than Japan, right? So the second question is, what is the regulation of Japanese government to decrease the microplastic?
Okay, thank you very much for the questions, Dr. Tomoya. Okay, please.
Oh, thank you for question. So the first question, the answer of the first question is simple. Is depending on the waste management. So in Japan, so the most of plastic waste is banned. But undeveloped country, so plastic waste is buried so in the land. So this is a very this may be the potential of plastic waste in the future. So because plastic waste may be fragmented due to the ultraviolet and the high temperature on the land. So buried plastic waste is a potential to generation of microplastics in the future. So this plastic particle eventually is transported to the ocean. Yeah. It's the difference among countries or difference of plastic emission among the country is depending on the waste management. Right? Yeah. Yeah.
What about the regulation? No regulation.
No.
So
Yeah.
far. Okay. Good. Okay, thank you very much. Anyway, apologize if we are out of time. So I think should you have questions, please direct to the speakers directly, whether it is over email or whatever. Okay, thank you very much for your joining with us, and it is pretty nice for us to see you here. And we have a very good discussion for today. And again, thank you very much for these three speakers for well respected presentation. Okay, from me, thank you. And we finish this discussion. Okay, thanks. And Assalamualaikum warahmatullahi wabarakatuh.
Thank you. And bye-bye. Sawadee.
Now, we will have hand over the plaque and certificate for our speakers and moderator. To all speaker and moderator, please come to in front of the stage.
We would kindly invite the Dean of the School of Postgraduate Studies, Dr. R.B. Sularto S.H.M. Hum, the second Vice Dean of the School of Postgraduate Studies, Professor Dr. Tri Retnaningsih Suprabhawati, M.A.P.P.S.C., and the Chairperson, Professor Dr. Insinyur R. Rizal Isnanto, S.T. M.M. M.T. IPU, ASEAN Engineer, to come onto the stage and give the momentous appreciation for all speakers and moderator as a sign of our gratitude. First, we honor to give the plaque and certificate for Associate Professor Tomoya Kataoka, PhD. The second, we honor to give the plaque and certificate for Professor Hadianto. Third, we honor to give the plaque and certificate for Associate Professor Sangdam Monsoon. And last, we honor to give the plaque and certificate for Mr. Agung Budi Prasetyo, PhD, as a moderator. Please to all speakers, moderator, the Dean, and the second Vice Dean, and the chairperson to take position to take a photo.
Let's give a round of applause for our speakers and moderators.
Please to all speakers, moderator, the dean, the second vice dean, and the chairperson are welcome to the return to your seat. Well, thank you to all speakers and moderator for sharing your best knowledge. Now we will have a lunch break until 1 p.m. We would like to inform you that after break, all participants can go to the presentation room based on your schedule. Room 2A will be in Borobudur 1 room on the first floor for information system. Room 2B will be in Borobudur 2 room, the first floor for information system. Room 2C will be in Prambanan room on the second floor for environment. Room 2D will be in Plausen room in the second floor for energy. Room 2E will be in Cebu room on second floor for multidisciplinary.
We also inform you that after the parallel session, please back on this room for closing ceremony. We would like inform of you there is a booth outside in the main room that you can visit for upcoming event.
This booth is organized by a cluster for paleolimnology. The CIPALEM is research community of Diponegoro University in collaboration with BRIN, National Research and Innovation Agency in Indonesia. There is an advanced workshop on sustainable water management that organized by CIPALEM. This event will be held on August 15, 2023 in hybrid mode. If you are interested to take place this event, please contact the committee or visit the booth. Thank you.
And now, all participants can enjoy their lunch break until 1 p.m. Thank you.